Verifying or proving trigonometric identities is different than solving an equation and thus requires different steps. While every verifying problem is different, following these steps will help. First, I recommend that you work on the side that is more complicated and you leave the other side alone. Then you should use algebra to simplify if possible. And by algebra, I mean you can factor, you can get common denominators, you can multiply by conjugate, whatever it takes to simplify. Once you've done as much algebra as you can, you should move on to trigonometric identities to convert everything in terms of sine and cosine. And then you go back to algebra for simplifying, and then back to the identities, and you alternate between algebra and identities as much as you need to until the side that you are working on is equivalent to the side you left alone. There are many trigonometric identities that you learn. These tend to be the most common identities that are used for verifying. These are relating cosecant with sine, secant with cosine, cotangent with tangent, and they also include your Pythagorean identities, which can all be modified for whatever you need them to be. I think the best thing for us to do at this point is to actually work through an example, going through the steps to make sure that you understand. Let's look at example 1. I have tangent of theta times sine of theta equal to secant of theta minus cosine of theta. And remember, I'm not solving, I'm verifying. So for that reason, I'm going to go through these steps. First, I'm going to work on the side that is more complicated. In looking at these two sides, knowing that I'm probably going to be working with having to get common denominators, I'm going to go ahead and focus on the right side because I know that subtracting fractions is more difficult than multiplying them. The second step is to use algebra to simplify if possible. Looking at secant theta minus cosine of theta, there's nothing algebraically I can do with that, so I'm going to move on to step 3. I'm going to convert all the expressions to sines and cosines. I see here that secant is equal to 1 over cosine, so I'm going to go ahead and convert my secant to 1 over cosine. And for sake of space and time, I'm going to leave out theta in my problems until the end. That can be a choice you can make, kind of depending on what your teacher needs. But know that I do understand it's 1 over cosine of theta. I just want to make sure I don't run out of room. I'm going to go ahead and bring down what the original problem had, which was cosine theta. No need to change it. It's already in terms of cosine. Now that I've converted the expressions to sine and cosines, which is step 3, I'm going to use algebra to simplify. Just like I predicted, I'm going to have an issue with fractions here, and I need to get common denominators, so I'm going to multiply top and bottom by cosine. Just to stay consistent, I'm going to go ahead and remove that theta that I told you I wasn't going to put, and then habit made me go ahead and put it. Anyways, what I have now is cosine squared over cosine, and then this thing originally was 1 minus cosine. Since I have common denominators, I can continue with my algebra and combine them together. 1 minus cosine squared over cosine, the common denominator. Now that I've done as much algebra as I can, I'm going to go on to step 5, going back to trig identities. I see here that I have 1 minus cosine squared on the top, and I understand that I'm able to manipulate these identities as I need to. For instance, if I rearranged this equation, I would get sine squared of theta is equal to 1 minus cosine squared of theta. That's what I needed in this equation, so I'm going to go ahead and replace the 1 minus cosine squared theta with sine squared. And then I'll bring the original cosine. Now that I've done as much trig as I can, I'm going to go ahead and go back to algebra. I'm running out of room, so I'm just going to write this next to it. Sine squared I know is the same thing as sine times sine, and that's over the cosine. I know from my algebra rules that this can be broken up into, I'm going to bring it over here, sine over cosine times sine. I'm saying sine and then I'm writing cosine times sine. That's just a simple multiplication rule using algebra. And then now that I've done as much algebra as I can, I go back to trig. Sine over cosine I know is the same thing as tangent, so I'm going to replace sine over cosine with tangent and then bring down my sine. And then now that I am at the end, I'll go ahead and bring back in those thetas. And you see that I have ended up with tangent of theta times sine of theta, which is what I originally had on the left side. So I can say, yes, I have identified this, I've verified this, and the problem is complete. So just to refresh before we move on to more examples, you always start with the side that is more complicated. You use algebra to simplify if you can. You convert everything into terms of sine and cosine. Back to algebra, back to identities, back to algebra, back to identities, and you alternate as much as you need to until the side you're working on ends up being the same as the side you left alone. Let's go ahead and try another example. So here I have secant theta, sine theta being multiplied over a fraction where tangent theta is being added to cotangent theta. It's very clear that the left side is more complicated than the right, so that's where I'm going to focus my attention. Now that I've decided on which side to focus on, I ask myself, is there any algebra I can do here? Not really. No factoring, no common denominators, no conjugates, so I'm just going to jump right into the third step, which is turning everything in terms of sine and cosine. So I'm going to change this secant into 1 over cosine, and then I'm going to bring the rest of the problem down, which was multiplied by sine. I'm going to change the tangent into sine over cosine, and I'm going to change the cotangent into cosine over sine. And all of these were written on the page before as the most common identities that are used in this process. I have a lot going on here, so I'm going to work with the numerator first. 1 over cosine times sine over essentially 1 ends up becoming sine over cosine in the numerator. And then in the denominator, I need to get common denominators in the denominator. So I'm going to go ahead and multiply accordingly so that I end up with sine squared plus cosine squared over their common denominator of cosine sine. I've done as much as I can using the identities, so I'm going to go back to algebra. One of our algebra rules is that when you're dividing fractions, don't ask why. Flip the second and multiply. So I'm going to go ahead and write sine over cosine, and I'm going to multiply by the reciprocal of the denominator, which is cosine sine. And actually, now that I'm seeing it, couldn't I have continued with some trig identities on this one and changed that to 1? So why don't we just go ahead and do that now. To be clear, what I'm saying is sine squared plus cosine squared, that's a Pythagorean identity. We know that's equivalent to 1. Now, I'm still in the algebra aspect. I'm going to try to simplify as much as I can. If I have cosine in the denominator and the numerator, they can simplify out, so I'm just left with sine times sine, which is sine squared, and I'm going to bring back that theta. Remember, our original was to get it to be sine squared theta, which is what I did, and I'm going to go ahead and just bring that sine squared theta down and put a check mark next to it, meaning I have verified it. Let's try another example. In this problem number 3, I have tangent theta plus cotangent theta is equal to secant times cosecant. For this one, I am going to go ahead and focus on let's do the left side again, because in case I get common denominators, I would rather, I know that adding fractions and having to get common denominators is much more difficult than multiplying fractions. So first I'm going to decide, can I do any algebra on the left side? Nothing really I can do. So what I'm going to do next is go ahead and convert everything in terms of sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. Hey, this looks like our denominator from the last problem, so this should look pretty familiar. Go ahead and get your common denominators. Combine them together. All over cosine sine. Now that we've done as much algebra as we can by getting common denominators, I'm going to go ahead and use trig. The Pythagorean identity tells me that sine squared plus cosine squared is 1. and I'm going to bring that all over cosine. Now that I've done as much trig as I can, I'm going to go back to algebra. 1 over cosine times sine can be broken up into 1 over cosine times 1 over sine, so it's the reverse of combining them together. And then I go back to trig. 1 over cosine is the same thing as secant. I'll bring that theta back in. 1 over sine is the same thing as cosecant. I'll bring that theta back in, and hey, we ended up getting them to be equal. You can write this down here if you want. Some people prefer to kind of draw an arrow to show why nothing was done there. And then you can put a check mark because you have verified or proved that identity. Let's move on to some others. Thus far, we haven't needed to do algebra in the beginning. These next two will show you how you will have some situations where algebra is done. That was step 2. But let's go through the steps. Step 1, start with the side that is more complicated. Obviously, that's the left side. Step 2, do algebra as much as you can to simplify. If this problem was written as x squared plus 2x minus 3, it would be much easier for you to see that this is a factor problem. Just because it ends up having that cosecant doesn't change anything. This is still a factor problem. I know that this is going to break into x minus 1, x plus 3. But it's not x squared, and it's not 2x. It's cosecant squared and cosecant x, or theta. So instead of the x, I'm going to replace that with cosecant. So here's what this would look like. Cosecant minus 1, cosecant plus 3. And if I FOILed that, I would get back to the original. That's all over the denominator, which can also be factored. That's a difference of squares. So this would be cosecant minus 1, cosecant plus 1. Thus far, we haven't even had to involve trig identities. We're just using algebra to factor the top and factor the bottom. Continuing with algebra, because there's still more we can do, I see that this can cross off with this because they're being multiplied and divided, which cancel each other out. And without even having to use any identities, I have verified this. Cosecant theta plus 3 over cosecant theta plus 1 does equal the original right side. And we go ahead and put a check mark on it. So there are some cases where it's really just algebra. I didn't even need to go through the other steps. I was stuck on step 2 and I got all the way to the end. So just keep that in mind, that you may not need to do all steps, like how in the last problems we didn't need to do step 2 at all. In this problem, step 2 is all we needed. So it really is depending on what the problem is asking. Let's do one last example together. In looking at problem 5, it may not seem so, but I'm going to go ahead and work on the right side because I recognize that there could be something going on with the conjugate here. There's really no wrong way to do these. If you started on the left side, you would still get the correct answer. It's just a strategy for me to start on the right. What I'm going to do is multiply the top and bottom by the conjugate of the denominator. By doing that, on the bottom, I end up getting 1 minus sine squared because of the difference of squares, kind of like how we saw with the denominator of question 4, just in reverse. But on the top, I'm going to get 1 minus, I'm actually going to leave it as is for right now. Let's leave it as its factored form. I'm sorry, it's in its squared form, so it's 1 minus sine squared. We'll leave it like that. All right, since the bottom is 1 minus sine squared, I'm going to go to my trig identity and write the denominator as cosine squared. Remember, our numerator was 1 minus sine all squared. Since everything here is being squared, I could put them together in one big fraction that is being squared. Now, reverse of common denominators, I can actually break this up into 2 separate fractions now. So I could write this as 1 over cosine minus sine over cosine all squared. Because again, think about if I went forward with this, I'd get back to where I just was. And now I'm going to go into trig identities, glancing at what the original is. I'm going to change the 1 over cosine to secant theta. And I'm going to change the sine over cosine to tangent theta. That's all squared, and that is equal to the original, so I have verified this identity. In closing, just keep in mind that while every problem is unique, following these steps in order, understanding though that you may not do each step, but at least asking yourself if that step can be done, can lead you to a really simple process for how to verify these identities. Down below, I'll include a link for this document so that you can try practicing these on your own. I'll also include a link to other free resources that are related to not just trigonometry or math, but also other concepts that maybe you're struggling with. Best of luck!